Welcome back, teachers and educators. My name is Hilary Romer. I am a geoscientist and educator with the Saskatchewan Mining Association's Education Outreach Program. In the previous video, we explored the first lesson in the potash solution mining lessons called Dissolving Potash. Learners examined a piece of potash ore, which is made up of different minerals. They had to put on their chemist hats to learn how to separate the valuable minerals from the iron oxide minerals and clay by filtering out a solution that they made. Remember that these curriculum correlated lesson plans can be downloaded from the SMA website, and they're also included in the potash kit that is provided free to educators. In today's video, we will be exploring the next two lessons in the potash solution lessons called Recovering Dissolved Potash and How Do We Know It's KCl? To engage learners, ask them to explain to you what they learned about potash solution mining during the previous lesson. Reinforce the solution mining method in Saskatchewan is used because some of the potash deposits are too deep for conventional underground mining. The mining companies pump warm brine down a well into the potash ore where it dissolves the salt minerals. Then the salt solution is pumped up to the surface and to the mill where it is processed to recover the dissolved salts. During these next two lessons, learners will continue to be chemists. First, let's review some materials you might find useful for these lessons. You're going to need your filtrate or your solution of 2 dissolved salts from the previous lesson, a small container with a lid, such as a small jar from the dollar store, a bowl of ice cubes, or a refrigerator or a freezer. A hot plate is optional. Granular potash, which is included in your kit, a stir stick or spoon, a pop bottle funnel, and a coffee filter. And remember, there's always your cheat sheet task cards, recovering potassium chloride, KCl, or recovering your dissolved potash, and how do we know it's KCl? There are 2 main ways to structure this lesson depending on the age of your learners. However, both involve creating a supersaturated solution. You can make a supersaturated solution in one of the 2 ways using the dissolved potash solution filtrate from the dissolving potash lesson and the Ziploc of granular potash included in the potash kit. If using 100 milliliters or 1 liter of the filtrate, you should not exceed the 125 milligrams of granular potash. However, you can add table salt if you're making a bigger batch or individual batches and you don't have enough granular potash. For method 1, you need to dissolve the granular potash into the filtrate to supersaturate the solution at room temperature. You're going to stir constantly and keep adding it until it no longer dissolves anymore. In method 2, you're going to use a hot plate. There are 2 ways to do this. You can either reduce 100 milliliters of the filtrate to 500 milliliters. This way is the most realistic model, but not necessarily easiest to do. It takes a couple hours. You can use the other ways and tell students that you are cheating to make it easier. Or, by using a hot plate, you can heat 500 milliliters of the filtrate, remove from the heat, and add the granular potash until it no longer dissolves. By heating the solution, it allows more salt to be dissolved, which creates better crystals when cooled. However, you do not need to use heat for either lesson structure. Now that you have your supersaturated solution, we can look at the different lessons for younger and older learners. For younger learners, you could focus on evaporating the salts back out of the supersaturated solution to demonstrate that they did not disappear. For this, students pour about 2 centimeters of the supersaturated solution into a jar and wait for it to evaporate over several days, recording observations of the resulting halite and sylvite crystals that form. For older students, the focus can be on the method to separate the 2 salts from the supersaturated solution, so the final product is pure KCl. For this, have learners interpret a graph comparing the solubility curves of the 2 salts at different temperatures. Learners will pour some of the supersaturated solution into test tubes or small containers or jars and place them into an ice water bath or in the refrigerator. It may take 30 minutes before any crystals form. The first sign may be a thin layer on the surface. As crystals form, they will drop to the bottom. Then filter the crystals out of the solution. Note, it could be placed in the freezer overnight to precipitate more crystals and filtered the next day. The crystals on the filter paper are KCl. The NaCl remains in solution at the colder temperature. If we were to heat or let the remaining filtrate evaporate in the glass jar, we would see the NaCl crystals form up the side of the jar. An extension of the lesson could be a discussion about the solution mining process, how mining companies pump the solution to the surface and store it in large holding ponds, where the cold temperature of the air cools the warm brine and causes the sylvite, KCl, to precipitate. In the summer, the precipitation is done inside the mill. Ask learners if more potash is produced in the winter or the summer. More potash is produced in the winter because it is colder. In today's video, we explored 2 lessons in the potash solution mining lesson plans called Recovering Dissolved Potash and How Do We Know It's KCl. Join me in my next video where we will be creating a working potash solution mining model. Remember to check out the SMA website for many free resources and lessons, or you can email us at education@saskmining.ca if you have any questions. On behalf of the Saskatchewan Mining Association, thanks for watching. Remember, stay curious, ask questions, and never stop exploring. Bye.